Acceleration is defined as any change in velocity. Anytime the velocity of an object changes, we define that as acceleration. In physics, we do not make a distinction specifically between acceleration and deceleration, the terms commonly used in the English language. We refer to any change in velocity as an acceleration, whether the object is speeding up or slowing down, or even changing direction. Remember, velocity is a vector, which means it contains both a magnitude, the speed, and a direction. So if you change the speed or change the direction, you are accelerating the object. The basic formula for acceleration is acceleration equals the change in velocity over the elapsed time. We will commonly rewrite this change in velocity, final velocity minus initial velocity, and generally our initial time is 0, so we write that way. You occasionally will also see this formula cross-multiplied and then add the initial to both sides. So the final velocity equals the initial velocity plus acceleration times time. So the two most common versions of this formula that you will use are that one and this one. They're the same formula, just rearranged. Because acceleration is any change in velocity, so any change in speed or direction, you can accelerate by speeding up, slowing down, or changing direction. So your car actually has 3 accelerators in the car: the gas pedal to speed up, the brake to slow down, or the steering wheel to change direction. Now, the direction of acceleration is something that's complicated for a lot of people. Acceleration has a direction just like velocity. It is a vector quantity. The typical units for acceleration are meters per second squared. You're dividing meters per second, velocity, by time, seconds. So meters per second, or meters per second squared. If you're accelerating in the same direction as the velocity, you will see the speed / velocity increase. One way to think about this, and we'll get into force in a later chapter, but if you were to push someone, you're going to cause them to change their velocity. You're going to apply a force, which causes an acceleration. If I push you in the same direction you are moving, you're going to go faster. Same concept here. If the acceleration and velocity are in the same direction, both positive or both negative, the speed or velocity will increase. If the acceleration is in the opposite direction as the velocity, here's a case where the speed or velocity will decrease. So think about if you wanted to stop someone. If they were coming towards you and you wanted to stop them, you'd push them in the opposite direction they're moving. You'd cause an acceleration in the opposite direction, which would cause them to slow down. So whenever you have an acceleration in the opposite direction of motion, the speed velocity decreases.